It's time to learn some science.
To learn about the effective gravity on Mars.
We're on Earth, though.
Yes, he's testing it with the Mars Muno 3000.
Now, if Mars is smaller than Earth, is there as much gravity?
That is what Space Monkey intends to test.
All right, let's see Space Monkey go.
Throwing the ball of ribbon.
All right, well, that was pretty cool. How about Monkey?
Nope, it's a balloon.
All right, that fell a little slower.
Now, we don't have any more things. What should we throw next? You.
Oh, my goodness. Oh, he's still alive. Awesome.
Yes!
So the moral of this story is, don't let your kids try to demonstrate because they're all over the place. And two, let's think about this for a second. Which one fell the fastest? Monkey, right? Less air resistance, right? Falls through the air, all right? But the ribbon and the balloon, well, that's another story because they have a bigger surface area, so air is able to push up on them as they fall down, and therefore slowing their progress down to the earth. Say bye, guys.
Bye.
Okay, fellas. So what did we learn today? Anybody? Steve? Rick? Nothing? Can you say gravity? What did we learn about gravity? Anybody? Steve? Rick? Help me out here, bud.
Okay, so here we are, and you'll notice on my table I have a plastic bag, which is going to represent the fabric of space. Okay, and I have three balls here, and what I'm going to demonstrate real fast is kind of what we looked at last week with our Fed activity. So we learned that gravity is dependent between two objects is dependent on two things: the distance they are away from each other and their masses. Okay, so if we look at these different balls here, I have a hockey ball and a marble and a soccer ball. Okay, and you'll notice they're different sizes and they're different masses. All right, this one weighs the medium amount, this one weighs the least amount, and this one weighs the most. Okay, so if we were to compare their gravities in space, all right, these two balls sitting this far apart from each other would exhibit a lot of gravity on each other. Okay, if I were to place this ball here, okay, that would be less gravity because the two masses are different this time around. The ball over here, the marble, weighs a lot less. All right, so there's going to be less gravity. Also, consequently, if I move the marble there further away from the ball, now there's going to be even less gravity because the distance is further. The closer things are to each other, the more gravity they're going to exhibit. Okay, and this is going to have even less gravity when I put these two together. The attraction between those two, that magnetic field, is going to be a lot less than, let's say, I replace it with this. If this planet should come into range there, now the gravitational pull between those two is going to be immense. Okay? All right, so let's take a look at this little experiment. I'm going to show you the first part of it. So we're going to use this orange hockey ball as the sun. All right, and it's in space here. And let's say this marble, all right, I have here, is going to come along, all right, and fly past the sun, all right, in space in a two-dimensional area when we're not involving gravitational fields. Let's see what happens to it. And you can see it just rolls right past. All right, let's go fetch it. All right, so what we're looking at here is the fact that without gravity, this ball in space, okay, or we'll just call it a small planet, as it goes by the sun, it really doesn't get sucked into it. It just kind of flows in somewhat of a straight line, okay? All right. So what we're looking at here is the fact that in space, there's actually stuff in space, even though it seems like it should be empty, okay? And that stuff is what we call dark matter. And this dark matter, all right, in space is actually warped by huge things in space, like the sun, like the earth. It sits in this dark matter and actually curves this dark matter. That's what gravity actually is, as far as we know. So, in the next part here, we're going to take a look at exactly what I mean. See ya. Okay, so here's what I've done. I've taken that same plastic garbage bag and I've stretched it across an area here. And this is going to represent our dark matter in three-dimensional space. Now, what we got to understand about gravity is things have more gravitational pull the more massive they are. Okay, so if something's more massive, they're going to warp this dark matter, this fabric in space more. So let's take a first look at this marble. And if I put a marble there, okay, what you should notice is it kind of bends that garbage bag a little bit, right down there where, where it's at. Now let's get something a little bit more massive, like, for example, the hockey ball. My marble's running away from me right now. Hold on. Okay, the hockey ball. Now, you'll notice that it bends. This is curved into it with a little bit more steepness, right? Okay, now let's take a look at the soccer ball. And what you should notice here is that it really bends that plastic bag. So, what's this mean? Well, in space, let's say we have our sun here, and we put it here. And it's bending that fabric. Now, if I were to take this ball now, this marble, and roll it, let's see what happens now. Whoa, you see it curve right around it. And eventually it comes back to it. So gravity basically is this force of attraction between two objects. And you can see how, as it comes back, watch. Oh, maybe not. It's hard to do holding the camera and doing this. Go like that. Oh, right at it. Boom. Yeah. You see it bends, it goes right to it. Okay? So that's, yep, see it? Pulled it right to it. All right, now, that looked pretty cool. Now let's get something even more massive. Let's get a really massive sun in there. All right, now let's roll it. Boom. All right, it pulls it. Yeah, there we go. Search for it. With a greater bit of gravity. Now, if we increase the other ball here, okay, all right, you can see what ends up happening is eventually these things get pulled together. And if it's going around like that, okay, eventually, all right, if it's going with enough speed and the gravitational pulls it, it might end up pulling it into an orbit like that, and it'll continue to orbit around if it's going the right velocity. All right, and you're going to learn about that in our next gizmo activity when we talk about orbiting the Earth. Okay, so that's it for now. Bye.
Okay, guys. Hey, that's not funny. All right, listen. So what did we learn today? You're really starting to irritate me, dude. We learned about gravity. Yes, we did. Listen, this is your last warning, dude. I'm telling you right now. God, are you kidding me? Man, those hamsters are killing me. They can't do anything, right? Can they?